Hey, good morning, chemistry class. Now, we're going to use an old PowerPoint I have here to talk about nuclear chemistry. And so, hopefully, you guys picked up from yesterday's assignment that we are going to be talking about the all important nuclear chemistry and all the crazy things that have been accomplished because of it. So, let's get started here. Now, we always associate this symbol right here with radioactivity, and nuclear chemistry deals a lot with that. Now, looking down here at the bottom, we also see this right here. This is the Greek letter alpha, this is beta, and this is gamma. All three of these play a very, very, very important role when it comes to nuclear chemistry, and I'm glad that you're along for the ride to figure out what it is. So, let's go on to the next slide here. For your information, historical perspective. And so back in the day, we had Henry here, and I believe his last name is pronounced Becquerel, and it was in 1896 that he discovers that natural radioactivity is a thing. Now, I talked to my ninth graders about this, and it's really interesting to think about, but there is actually a lot of people who used radioactive substances back in the early 1900s, and they thought radioactivity was a very good thing. They'd actually use it for things like health, and they had radioactive water they would give people to drink that they said would make them feel better, which is absolutely crazy, and we know is definitely not something good nowadays. But back then, when our friend Henry here discovered it, it was a pretty nice thing, wasn't it? It kept you warm. We'll go more into that as things go on. Now, here's some more right here, and then we have Marie, and I can't remember her last name right here, but that's not how I really know Marie, quite frankly. And she's a Polish chemist, and she marries Pierre Curie. And this is where Marie Curie, the famous chemist, who was very, very, very important when it comes to nuclear chemistry, gets her name from, or Madame Curie, as some people say. Now, Marie died from leukemia caused by her exposure to radiation. This is where all those things I was telling you about, especially back in the 1920s, they actually would put it in their clothes, and they would say they were able to go out in the freezing cold with just one layer of clothes on. Well, yeah, but would you imagine how much terrible it would be getting leukemia from that? Now, Pierre was killed while crossing the street when he was hit by a vegetable wagon. What an unfortunate way to go. But this freed up Madame Curie's time to actually study more when it came to nuclear stuff and gave her the drive she needed to keep on going. So, going on here, another big guy in this is Ernest Rutherford. And this is back in 1899. He discovers alpha, beta, and gamma radiation are all different types of radiation. And over here, you actually get to see a little bit of a diagram of what he did to actually see this. So, you've got a magnet, and you've got a radioactive sample in a lead block. Now, there was this tiny opening at the top of this lead block, and it would put out emissions. And he was able, using this magnet, to separate the three types of emissions that were coming from this one sample into alpha radiation, gamma radiation, and then over here, beta radiation. Now, we're going to talk about all of those things in a lot of detail later on, but not now. We're going to get to that a little bit later. So, we also need to define what exactly a nuclear reaction is, or nuclear reactions. So the first note here says involve changes in the composition of nuclei. Now, nuclei, as you guys know, is the center of an atom, and so it's changes involved in those. We talked about the changes on the outside, the electrons, in bonding and things like that, but now we're dealing with what happens when you change the inside. What's going on? Now, accompanied by the release of tremendous amounts of energy. So that's a very interesting thing when we look at it. there is a lot of energy involved in these nuclear reactions, which is why we use them to our advantage to create nuclear power. And a lot of the electricity that you're enjoying right now actually comes from that nuclear power. So that's something to think about there. Let's keep on going. Nuclear fission is very interesting, and this is when the splitting of a heavy nucleus happens and it turns into lighter nuclei. And so you get this nucleus here, and then through a process, whatever process that might be, especially in nuclear reactions and radioactivity, it's very random actually that this element, this molecule right here, will just break apart, and this one nucleus changes into 3 different nucleus. So you got a nucleus here, we got a nucleus here, and a smaller nucleus over here. And this is a big part of nuclear fission, and it happens very, very often in the nuclear realm. Now, nuclear fusion is a bit different, and this is when you get a bunch of light nuclei like these guys here. You've got only 2 things, and then they get smashed together, and that creates a lot of energy as well. And it's actually a very, very, very cool thing to see. And this diagram here, and you can see that these tiny molecules, they form together, and that is nuclear fusion. So let's go back. Fission is breaking apart. Fusion is putting them together to produce a heavier nucleus. Let's keep on going here. Now, give me a second, I forgot how to pronounce this. Nucleides. Different atomic forms of all elements. Most small nucleides have equal numbers of protons and neutrons. Some nucleides have magic numbers of protons and neutrons and are especially stable. Now, being stable is good because when you're not stable, stuff like this and this happens very, very randomly. And one of the worst things to happen in a chemistry aspect is having something random go wrong, especially when it comes to nuclear things. This could lead to lots of energy being given off, causing explosions. And so there's a lot of stuff going on here. Now I'm going to end this part of the video. I'm going to see how far along I am, and if I need to do some more for today's lesson. I probably do though, so don't get your hopes up too high. Thank you for listening. I will see you, well, probably a little later on.